Okay, this is from the book here, Prevent and Reverse Parkinson's Disease, Chronic Fatigue Syndrome. This is how big the book is. It's a pretty thick book. It's about just about 500 pages. Um, and so I'll talk a little bit about mitochondrial inhibitors, a few interesting things about it. You know, those of you who've seen lots of my videos know that I've talked about mitochondrial inhibitors plenty of times, but there's a few interesting things here. Chris Palmer, psychiatrist at Harvard, you know, he's sort of the pioneer of the idea of the metabolic theory of mental health disorders. You know, what I like about him is he admits the truth that antidepressant medicines don't work. They work very poorly, very little advantage, if any, over placebo. So he talked about how the psych drugs for so many of the mental health disorders don't work well. Okay, other people like Bragan have said they all cause a lobotomy. Grace Jackson said pretty much the same thing, and a lot of others have said the same. But the point he felt was that people are eating unhealthy diets, and that's causing metabolic problems, and that's leading to mental health disorders. And there's a lot of reasons why that would be true. I'll talk about it later in the book. But, you know, just for example, you get leaky gut, then bacterial endotoxins get across your gut. When you got leaky gut, leaky intestinal barrier, you got leaky blood-brain barrier. The bacterial endotoxins, LPA and LPS and LTA, will then get access to the brain parenchyma. The microglia will sense them, bind them with their pattern recognition receptors, and think there's an incoming bacterial invasion. They'll release their toxic chemicals, and that'll cause collateral damage to the brain because they're trying to sterilize the vicinity area, and that'll cause collateral damage to the adjacent brain cells. And you do that every day for a couple of decades, and your cognitive function is going to drop. Okay, the highest intelligence sees connections where no one has seen them before, Aristotle. So mitochondria, you know, they're the energy powerhouse of the cell. ATP is like the $20 bill for getting work done in a cell. It's the energy molecule of the cell. It means adenosine triphosphate. Okay, about 95%, 90-95% of ATP is made in the mitochondria. Under resting conditions, the heart burns mostly fatty acids, but during stress, it'll burn more carbohydrates. The brain wants to burn glucose. That's the brain's favorite fuel. So I had read the Brownlee paper, the greatest paper ever written about diabetes, and noticed how fat, especially sat fat, blocks intermitochondrial membrane electron transport. And I sort of knew, I had an inkling here and there of other things being bad for mitochondria, so I figured, there's got to be a lot more to this mitochondrial inhibition stuff. So I went through all my biochem books, and I had previously, when I was a young guy, considered being a biochemist, so I own about 7 biochemistry textbooks, college, med school level, and not a single one had anything on mitochondria. 0, not a ninguno. So I'm like, that's weird. There's got to be a lot more about mitochondria inhibitors. By the way, here's a mitochondria. It's really sort of a symbiosis with the bacteria is what's thought to be the case. So there's an outer mitochondrial membrane, OMM. There's the inner mitochondrial membrane, green, the IMM. And that's where electron transport occurs. That's where ATP is made. There's the intramembranous space between the outer and the inner mitochondrial membrane. Inside the mitochondria is a matrix. That's where Krebs cycle runs. The intramembranous space is where the protons are pumped. And then the gradient is harvested when the protons come back into the matrix. Okay, I got lots of videos about mitochondria in more detail. A good one at VegSource, a good one at Be Green with Amy. Okay, here's the inner mitochondrial membrane, and these are the complexes 1, 2, 3, and 4. And electrons are passed down along these, sort of like rolling downhill towards progressively stronger grabbers of electrons. The ultimate electron acceptor is oxygen. The protons simultaneously are pumped into the intramembranous space, establishing almost like an air pressure gradient. It's a proton electrochemical gradient. The charge across the inner mitochondrial membrane is very high, like around negative 160 millivolts. So when you let a proton come back in, it comes in under a lot of energy, and that'll spin this intramembranous protein there called ATP synthase. And when it spins, it catalyzes the coupling of a phosphate with ADP to remake ATP, adenosine triphosphate, for energy. And it makes a lot, and it's very efficient. With oxygen present, it makes 18 times as much ATP per molecule of glucose than does anaerobic metabolism in the cytoplasm with glycolysis. Okay, here's a little more detail. In this drawing here, you can see sometimes coenzyme Q will drop an electron down into the matrix. It'll combine with oxygen to make superoxides. The mitochondria is expecting that, and it's ready for that. And it has superoxide dismutase. And, there's catalase. These enzymes will change the superoxide, a potentially harmful free radical, and they'll just neutralize it and make it into water. Okay, but when you have excess sat fat, it'll start blocking in this region between, around coenzyme Q and complex 3, and then you'll start dropping more and more electrons. And when you drop too many of them, you can overwhelm superoxide dismutase. Okay, here's just showing you a couple things about the electronegativities. Electronegativity of oxygen is super high. It's the second highest in the periodic table of elements after fluoride. Fluoride's got the highest electronegativity, meaning the strongest desire to grab electrons. One definition of a pathogen is an electron stealer, an oxidant, and fluoride is the worst. That's why it's so pathogenic. This vertical column of ions is the halogens, and they all kill stuff. Fluoride, chlorine, bromine, and iodine. I mean, iodine used to be our standard prep. Now we use chlorine, chloroprep. Okay. Tap water sterilized with chlorine and fluoride. Okay, this is just showing the same principle. And really what it's like is like a nuclear power plant. You split the atom. So the hydrogen atom is split into its proton and its electron. The proton is pumped into intermembrane space. The electrons are passed down through this series of complexes like we talked about. And then you let a proton come back in and you make ATP with that. But that's pretty impressive, splitting the atom. It's a nuclear power plant. That's what I mean by how smart God is. He made a nuclear power plant, miniature, long before man had any inkling of it. Okay, so anyways, if you want your mitochondria to work well, you need to avoid mitochondria inhibitors. And there was none in the 7 books, but when I started looking them up in the papers, I was amazed. I quickly found 10, 20, 30, 40, 50, 60, and then all of a sudden I had 100, 120. And they're real common things. Tylenol, statins, metformin, antidepressants, both the tricyclic antidepressants and the selective serotonin reuptake inhibitors like Prozac, antibiotics like fluoroquinolones, heavy metals, aluminum, lead, cadmium, and then these things sprayed on processed food, glyphosate, atrazine. So here's almost like a graphical abstract of all these things sprayed on non-organic food, and all these other mitochondrial inhibitors. Typically in non-organic food and processed food, they'll put succinate dehydrogenase inhibitors, fungal inhibitors, to prevent mold growing in the food. And those are very often complex 2 succinate dehydrogenase inhibitors. A lot of common things here: fluoroquinolone antibiotics, beta-lactam antibiotics, aminoglycoside antibiotics, omega-6 cooking oils, their metabolic byproduct, hydroxynonenal. Chronic corticosteroids can inhibit mitochondria. Tetracycline's another antibiotic. Beta blockers, a common drug for treating hypertension, for example. Arsenic. Let's see, what else? Potentially, of course, cyanide. Potentially some of that in almonds. Statins and metformin are super common. There's a whole bunch of other common medicines in there. Okay, I'll do this list of mitochondria inhibitors with the next one, so I hope you found that helpful.